In this video, we're going to be talking about global routing. At the end of this presentation, you will be able to explain why we cannot use intra-domain routing protocols for inter-domain or for large-scale networks. And we're going to look at also basic operations of inter-domain routing. We're going to discuss first two concepts. One is scalability, and the other one is administrative autonomy. So let's talk about scalability. When you have a large number of routers in a network, these are going to have to exchange lots of messages and use lots of communications overhead to run a protocol like the ones that we've studied before, like distance vector or link state. It also means that not only that the communication overhead is going to be large, but we're also going to need a lot of computing power to run the algorithms that we have studied before. Additionally, you will need lots of memory to store all the routing information from all the different routers in your network. And if you consider today that the internet has hundreds of millions of routers, it would be impossible to run the same protocols as distance vector and link state use in a very large network. Now let's look at the problem of administrative autonomy. So the internet is a very large collection of routers and ISPs, and there's large ISPs, the tier 1 ISPs, and smaller ISPs. And any of these organizations should have the flexibility to operate and use their own routing protocols, any routing protocols they actually decide to run inside their organization. And also we need the flexibility that an organization could maybe want to hide certain aspects of their networks. And this is not possible if we use the same intra-domain routing protocols like distance vector or link state that we've studied before. So having said that, let's introduce the concept of autonomous systems. So when you group a set of routers that belong to just one organization, you can create something called an autonomous system or an AS. And sometimes an organization, usually when it's large enough, might create a couple or more than one autonomous system inside their organization. Inside the autonomous system, so this green circles or ellipses represents autonomous system. This could be autonomous system 1. This is autonomous system 2. And inside the autonomous systems, we're going to run an intra-domain routing protocol. Usually it is link state like OSPF. It could also be distance vector. And how do we identify the autonomous system is something we call the autonomous system number. An autonomous system number could be either a 16-bit number or a 32-bit number assigned by the usual numbering institutes for the internet, like ICANN, which is a registry. Okay, let's start talking about inter-autonomous system routing or inter-domain routing. So remember, this green ellipses are autonomous systems. So this is autonomous system 1, autonomous system 2. And inside the autonomous system, we run our intra-domain routing protocol. So this could be, for instance, link state. This could also be link state or distance vector. But between autonomous systems, we're going to be running an inter-domain routing protocol. Think of it as an international communications. Okay, so between autonomous systems, we talk an inter-domain routing protocol. And the one that is widely used today is BGP, and BGP stands for Border Gateway Protocol. And as we'll see, it is a decentralized protocol, so there's no single controlling entity that controls how BGP behave. And it's asynchronous, meaning that messages are exchanged at different times between the different autonomous systems. In nature, it is similar to distance vector. It's not exactly distance vector because it's not an optimal protocol, but it's similar in structure to the messages that it exchanges in between autonomous systems. Okay, so let's keep talking about BGP. So BGP, what it helps you to do is to find destinations outside a particular autonomous system. And how it's going to do this, it's going to share routes, and the routes are going to have a different structure, and as we'll see a different video than in distance vector or link state. But this also going to teach you how to reach certain networks. So for example, a route might tell you how to reach all the 1024 hosts in this particular prefix. So basically, BGP lets you, your organization, your autonomous system, learn how to reach different prefixes on the network. Now when we look at the goals of BGP, so the first one is to obtain what's called reachability information. So BGP is not an optimal protocol. So because it's a reachability information, BGP is not optimal. It's not optimal, meaning that it doesn't look, or it doesn't guarantee you that it's going to find you the best route, but it's going to find a route to the destination. And there's a set of rules that help in selecting which route is going to use. And the first criteria, as detailed in a different video, is that BGP is going to work based on the policy and policy set by the administrators of the autonomous system.